Hello everyone, welcome back to Advent of Code. We're doing 2020 day 19 today. I've already read the problem description, as I have for most of the recent ones, and I thought I would point out there's a little sea monster here, which is pertinent because we're doing a problem about sea monsters today. Anyway, here we are. Day 19, monster messages. You land in an airport surrounded by dense forest. As you walk to your high-speed train, the elves at Mythical Information Bureau contact you again. They think their satellite has collected an image of a sea monster. Unfortunately, the connection to the satellite is having problems, and many of the messages sent back from the satellite have been corrupted. They sent you a list of the rules valid messages should obey, and a list of received messages they've collected so far. The rules for valid messages are numbered and build upon each other. For example, 0 is 1 and 2, 1 is A, 2 is 1 and 3, and so on. Some rules simply match a single character. The remaining rules list the sub-rules that must be followed. For example, the rule 0, 1, 2 means that to match rule 0, the text being checked must match rule 1, and the text after the part that matched rule 1 must then match rule 2. Some of the rules have multiple lists of sub-rules separated by a pipe. This means that at least one list of sub-rules must match. The ones that match might be different. Okay, yeah, sure. So basically, there's no loops, which will make things simpler. We can just build like a tree. This is something that I mentioned early on in the season. Was I wondered if like text processing is the theme this year, and like if the last couple days weren't enough to be sure, this really is. We're being asked to implement a parser for parsers, or like a compiler for parsers or something, right? Because this is a language definition, and we're meant to consume it, parse it, and turn it into a parser for that language, which should be exciting. I think not that hard, though, with Parsec, because we can easily parse this into a data structure that represents the original input format, and then fold that data structure. It'd be we would parse it into a list of rules, and then turn that into a map, and then we would traverse the map to. So it would be a data structure that's not like a tree, but an indirect. We use the map as the layer of indirection. Anyway, and it would be easy to consume that and produce a parser, and then you can run the parser on an input just as you would any other parser. So we should be able to actually like almost write a compiler, right? Which will be pretty cool. It might take some time. Like I don't think it's going to be a super fast problem, but I don't think it's going to be as like long as it sounds if you say they're asking us to write a compiler. So let's just get started here. We don't need applicative do because we're doing. I mean, like we could parse this with regexes instead of with Parsec, right? This input format is very very regular, very simple. Let me does text regex applicative chain, does it have like chain L or whatever? Because it seems like you couldn't you? If I search this for like chain, oh hang on, no, that's searching packages. I want to search, I guess, the index for this with many. We have many and okay, so it doesn't. Oh, all right. So Parsec seems like reasonably suitable and also like more convenient because it has more of the helper functions we'll need. So let's actually go look at yesterday, day 18, for the imports we're going to want. These all seem pretty useful. Yeah, probably want all of these, in fact. Don't need this twice, of course. Sorry, had dinner not too long ago and can't quite get the whatever to stop making me cough a little bit. So let's, I guess, just define a data type to begin with. A data rule, let's say. We could be more generic and make it a rule of A, but we know A is a character, so like why? So rule is one of, I guess, two things? Sure. It's either lit of a character, or else it is an alt of a list of rule. Because each well, actually, let me look at our input. It could be that, yeah, right, because every rule, right, is either a literal for a single character, or it's one or more subrules separated by a pipe, where on each side we have some number of things. It looks like in the input it's almost always two, but I'm pretty sure there's some where it's just one. I couldn't find anywhere there are three, but there might be some. So anyway, we'll have the or be like implicit, and we'll say it's a, for if we have a rule like this, we'll represent it as a list of one element, and that one element is a list of two elements, right? That's how we're going to represent this. It's not like that useful to be more explicit, I don't think. So that's simple enough. And what we need is, let's say rule is a parser for rule. Rule is do, I suppose. Let's define int again. Ah, a rule is more than that, isn't it? It's a rule of int and production, let's say. And a production is one of these, because every rule is numbered, and that's important. So int is read of some digit. Cool. So rule is label int, discard colon, I guess a space? I mean, I don't know. Is it? It must have string, right? Yeah, I remember it does. So we actually going to just discard the entire string colon space. And then it is either a lit or an alt. Easy, right? Ah, not quite, because we now have to wrap that up in a rule and a production type. Rule label, like so. Where lit is char quote ignored. It's lit of, I think we don't need these parentheses, but I'm much more comfortable with them. Char, or any char? Char quote again. We need any char from here. Oh, and we need, no, we already got string, yeah. And alt is chain L1 of, now what is the type of chain L1? It takes the parser for P and then the parser for the separator, as I recall. We can find out. Look at day 18, right? Chain L1, yeah. Of seek. Oh, seek is a built-in. We don't want to use that. Cat, let's say, for concatenation. And I guess the parser for combining sequences is like space pipe space. And cat is chain L1 of int, I guess. Ah, it won't be an alt of rules, but an alt of ints, pointers to other rules. Got it. Right. Chain L1 of int separated with cons char of space. Okay, my types are not right here. So cat is a parser for... Ah, I need to wrap an alt around here. Alt is a parser for production, I think. Yeah. And cat is a parser for list of int. Okay, these are both horrendously wrong. Oh, I want chain R1, don't I? Because I want this to be right associative. Okay, this all still fails to compile. What is the type of chain R1? Okay, it's just actually complaining about... A cat is a parser for list of int. So cat is wrong for some reason. We expected a parser for int, list of int, and we got a parser for int. Oh, sure. Because an int is not a list of int. I don't want chain R1 at all. I want like set by or something, right? Yeah, I just want a bunch of ints separated by space. That's way simpler. Okay. Int set by char space. And here I want alt of cat set by string of this. We need to import set by, of course. Okay, now it type checks. What's with the redundant bracket? Why are you highlighting this? And you're right, it is redundant, but I'm much happier this way. So let's slap some shows on these. Shoe. And make sure they parse correctly. So let's run parse rule of like 10 A. it needs a string. Unexpected S. Oh, do I have these in the wrong order? Is it supposed to be? Yeah, that makes sense, actually. It would take its arguments in the other order. Yeah, so it's a rule of 10, which is just a literal of A. And if we then said, well, actually, here's a more complicated rule. 10 is 1 and 2, or else it's 3 and 4. Nope, we broke it. Cool. Line 1, column 9, unexpected pipe, expecting digit. Ah, sep. I think we actually can just do this because we've already consumed the trailing space in our int parser. It's like a little bit weird, and ideally we should tokenize first. Like that would be the principled thing to do. Still wrong. Actually, we want sep end by though to indicate that it's okay for. Yeah, for the space can either indicate another one is coming or that it's over. So now we have an alternation of either 1 and 2 or 3 and 4. And this generalizes to, like, if we wanted to say 5 and 69, that would be fine. We can handle lists of more things, but we won't have to because our input doesn't have that. So now we have a parser. We want to write a compiler that compiles our list of rules. Well, we don't compile a list of rules, but a map of rules, right? So I guess what we need is okay. Let's import control monad reader. Does that exist? It does. Okay. It would be kind of nice to just be able to ask for the map and not have to like plumb it through manually. But plumbing it through manually is pretty easy. I don't know. Let's try using the reader just for funsies. Now we'll have a function called compile that takes an int, which is the starting point, which will be 0 for us, but it's still a good idea to have it take this argument for generality. And then it returns a reader from map int rule. Actually, map int production, because we don't care about the rules once we've gotten. I know I have to import data map. Give me a break. Import qualified data map as m. Import data map. We could use int map actually. Sure. And then we can just have an int map. And oh, it has to return something, which will be a. I mean, here's the thing. Right at this very moment, we don't actually care how the input string parses. We just care if it parses. But I would not be at all surprised if part 2 asks us something about the structure of the parsed string, right? Because what else really is there to ask us besides does this thing parse? How does it parse is kind of the only thing. So we need a data structure that somehow represents the parse. And that's actually the most complicated thing, the least obvious thing of what we're doing so far. We're building a parse tree, I guess. But I don't know what my parse tree is. Like, it's a 0. Maybe it just wants to know, like, how many production rules were used, for example. But I could say, like, okay, 0 had as children its leftmost rule, which contained 2 rules or something, and each of those. So maybe okay, so here we're gonna have a parser for parse tree. Compile is undefined. We need to define a parse tree, which I'm reluctant to spend much time on because I don't actually know whether I need it at all. It seems like I will, but I don't know what data I will need in it. So for now, let's just say parse tree is unit. There is no information in a parse tree. We're just going to parse to some junk, and it will either parse or not, and we'll use that as our information. So fine. Compile of root equals do, I guess. This do is in the reader monad here. So I guess first we have to say, or what are our productions? I see. Production asks m dot what order? This should take the index second, so like so. Case production. I guess like what might be a little fancier is to say ask m root. I don't know, whatever. This is fine. Like, we don't need a do, right? We could say asks m root bound to lambda case, like so, right? Which is just like clearly better. If it's an, what are our productions? If it's a lit, that should be simple, right? Lit of C is, we just need a parser for C's that returns unit, which is like char C unit. This should be an arrow because we're in a case, not a function. Why? Oh, right. Again, it should be like this. Inexhaustive, is that what you're telling me here? Thank you. Yes, I knew that, but I'm glad you were warning me. If it's an alt options, then it gets more exciting. We have a list of options. And I guess we want a choice. No, because choice is going to assume that, well, yeah, that's fine. Choice is going to not automatically do backtracking, but we can just, we need try here, I think. That's where try is? Okay. I mean, the funny thing is choice is just a sum, but like I like the one in Parsec better. Choice map try over something, right? We want to try each of the alternatives, and then whichever one matches is what we will produce. So try.cat, because each of them is a single concatenated thing. Okay. I guess, though, we kind of need... Do we need traverse? Oh man, using reader sucks. Why am I doing this? Get out of here. I just want a variable in scope. I don't want to have to like call asks to get it. Fine. It's an in-map production to... Oh, I don't need these parents now. M. And we'll just say like this. And now I shouldn't need pure anymore? Yes, I do, because this is a No, that's fine. Options. Where now we have to implement cat. Cat of parts equals we just have a list. How do you in Parsec combinators, I assume. Here? I want to concatenate several things. I have a list of parsers, and I want a parser for lists. Is that just sequence? Yes, it's just sequence. I don't need anything from Parsec. Okay. Actually, it would be better if we took our arguments in the other order, wouldn't it? Is then traverse, which is map m basically, compile m over parts. Why does this work, actually? I think it doesn't. I think it's just a coincidence. I kind of wanted this, right? And that is not redundant. I think this was using a different functor, like the function functor or something. So what's wrong with m here? If I look up... Oh. Right, because it was in asks, but now it's just case of, like so, right? Aha. What are you mad about cat for? Oh, because I already have it else. Yeah, no. I mean, you're right. I can just do that. So this is like unbelievably short, and I'm somewhat suspicious of it. How would we test it? Well, oops. Add MTL? MTL? No, get out of here. I don't want reader anyway. Okay, so we had a thing that parsed here, right? So let's add another one. Well, I guess I have to actually build the map, right? So I should implement prepare. That's fine. Our input then will be in a parser, I guess, right? A parser for parse trees? A single parser for parse trees? And prepare is going to be a little bit exciting, but not too bad, I think. Prepare is m.from_list composed with, well, let's say either parse error or input, and then I'll just like bind it or something. I'll rewrite main to handle this. I really should put something like this in my template so that I can handle error reporting a little bit better. So anyways, m.from_list. Like there won't be any parse errors, right? I wrote my parser, it's correct. Yeah, I don't know, forget this. We'll just cheat and say it's always right. m.from_list of if we have a list of, well, we want lines in here at some point, right? Okay. What's in between them though? We want to parse each one of them. So let's write map, or call it, I don't know. Actually, prepare is like more complicated because once we have the list of productions, or the list of rules, we need to compile them all. Okay, so let's split this up a bit more. It's compile rules composed with map parse rule lines, where parse rule of line equals parse. That's like, this is to give you better error reporting, and like I don't know. I actually kind of do care about it here. Let's be a little more careful. We'll say line text, line num text, zip 0, parse line show line num of, what did I call it? Rule? Rule, yes. Rule text. Why does this not type check at all? What is the type of parse? I thought it was in taking things in this order, yes? No, parse rule. Okay. There we go. And then, yeah, okay. And then we just need compile rules of rules equals let m equal m dot from list. Actually, let's just let it be compile m, where m is m dot from list map what is our thing called? It's a rule as the int first, so num. Oh, our productions don't have rules attached to them anymore. That's actually, that might be important when we're doing part 2, isn't it? When we compile them, no, this is fine. We have a parser for rules. Ah, we have an int map of production. But every time we actually parse something, we do know its number, right? We have root for the root rule, and then when we compile m, the new root is the number we're looking up. So actually, we do have the numbers in context, in scope, even though they're not like we have a rule, a production instead of a rule. Okay, fine. Num production for rule num production in rules. So okay, it's kind of looking like, oops, like this rule type kind of is not that great, and wouldn't it be nice if it were just a tuple, because then I wouldn't have to do this translation? But I don't know. It's a small price to pay to have meaningful domain types. I'm okay with it. So what are we upset about here? Parse rule. Oh, I need to compile something, right? Oh, compile m0? Okay, we're getting closer. Case this parse rule of right x left e error show e. So we need to really? What constraints? 0. Oh, it just doesn't know what kind of int I want to use. That's fine. We'll give parse rule a type just to make it happy. Parse rule is a function from list of int string to not list, but tuple to parser rule. Okay. Now why don't you like map? Use zip with. Oh yeah, that's way better. Sure, other order. Yeah, you got me. Oh, and now we don't need them tupled together. I don't know why today I didn't think to use zip with when I've used it plenty before. Okay. So now I would kind of like, oh geez. Why are you discarded a result of type string? Yeah, okay, fine, whatever. If you want me to declare that I'm ignoring it on purpose, I will. That's a fine compiler warning. I just I know what I mean, except when I do the wrong thing accidentally. So when I did the right thing, I'd rather not be corrected. When I did what I meant to do. Why can't the compiler just tell what I meant to do? I do appreciate the guardrail. I just didn't need it this time. And anyway, so now let's, for example, try compiling prepare of like this string follow, and also like that. Oh, actually, it won't work if we pass it stuff that doesn't exist. That's true. We have to actually write a real grammar. Okay, let's use the basic grammar from the. No, here we go. This. So this is a reasonable input. So let's prepare that. Let parser equal. Oops, I said parse. Parser equal. What is parser? It is an input. So we successfully parsed it. That's good. We got somewhere. And because it's an input, we know that it is... Where is input defined? A parser for parse tree. So if we then said parse, oh, I've ruined my parse binding. Okay, let's just go reload everything. Confirm that parse is like a normal thing again. Yes. Let's let parser be this. Parse, parser, standard in of the string AAB. Yep, it parsed. ABB? That didn't parse. ABA? That did parse. And that's, if we look at part 1, what was supposed to happen. Therefore, rule 0 matches AAB or ABA. So we have successfully produced a parser that returns right for anything that parses and left for anything that doesn't, given the input. So I'm very happy with that. So I think we can just write part 1, and it should be a piece of cake. So input to, what are we asked to do? How many messages match rule 0? Okay. And we're compiling with 0 baked in, which I assume will be useful for part 1 as well, for part 2 as well. Oh, hang on. Our input actually has more stuff, though. I forgot about that. Because after some amount of nonsense, there's the input strings. Okay. So our input's going to have to be a little bit more exciting. It's going to be a input of parser parse tree and then a list of string. Now we're going to have to be more we're going to have to make prepare a little bit more exciting. Okay, you got me. I will finally give this a name and not write this function composition. There's something like data list split, or I could use break or something. Let text equal lines s before after equal span not equal empty lines. in input of rules after. You know what? Let's just rules equals this. Text. Cool. So now if we prepare with the text we had before, it'll fail because there won't be any. Part 1 lacks a binding. I didn't define it, you're right. Part 1 undefined. Wait, what's going on? Not lines, text. And not text here, but before. I love that it's warning me that I forgot to use a variable. Redundant bracket? Here, I'm gonna leave that one in. You're right, it's redundant. I refuse, though. So if we now were to... this will fail. Really? There should be a failed pattern match in there. Maybe it's lazy? Let input p s's equal parser in length s's? Yes. Okay. So it does fail to compile. That's what I expected. But if I say let parser equal, like, these are the rules, and then new line, ABA, new line ABB, and then we do this again, it says there are 2 rules left, two lines left, and there they are. Map parse p s's. Oh, whoops, I put closing parenthesis in the wrong place. Oh, how nice. Look at that. The first one, it says, yep, it parsed. The second one, it says, no, I thought there would be an A, not a B. That doesn't match at all. Column 3 was wrong. So perfect. We get more information, even though we don't need it. So now it's very simple. We can just write part 1 to be basically what we just did in the REPL. Part 1 of input p s's equals length filter, well, actually length of, let's say, right unit, from right anything, in fact, from where something's not right. Tree where right tree is drawn from map parse p stood in essence. Everything about this is wrong. Parse is applied. Did I get it wrong again? What? I can't even. Where's my damn source file? Yes, I did. I did exactly the same thing again. Okay. It compiles, so let's like stack, not stack, we'll just stack run. That should be enough. Thank you very much. $206. That seems like a reasonable number. How many were in our input? I don't know, it's a little hard to tell. It ends on line 505 and starts on line 134, so about half. Okay, cool. Let's put that number in there. That's not right. It's too high. Oh dear. That'll be very difficult to debug. Too high, huh? Huh. What do we even try? We could try confirm. I guess let's make sure we wrote part 2 correctly, or the like part 1 and prepare and so on. Although they looked correct, by grabbing 206, huh? Yeah, by grabbing their input exactly. Like a test example. So here's a set of rules. Format. Okay, maybe I should just read. Oh, hang on. Maybe I should just read this and make sure I understood what we're supposed to do, but I'm sure I did. 4 matches A and 5 matches B. 2 matches either AA or BB. 3 matches AB or BA. Yes. Rule 1 matches 2, 3 or 3, 2. So this will accept, oh geez. Two pairs of letters, one matching and one non-matching in like any order. Sure. And then we match an A and then a set of matching things and then a B. Okay, yeah, that makes sense. I don't think I did anything wrong there. So here's their example input. Let's use this. Okay, and if we look at input.txt, input.txt, it follows a similar format. All right. So let's change this to be example.txt and run that. Three is what I came up with. The answer should be 2, according to the website. So that's good. It's not like we got something we couldn't reproduce on a meaningful input. Okay, well, we can enhance our parser now, or actually just part 1, to just output the actual results of parsing. And the parse errors will tell us what happened. We'll just part 1 of input ES's equals that. Let me close this here. So the first one parsed, and so did the third and the last. So which ones were supposed to parse? ABA BBB is supposed to match. That's the first one. And the third one, ABBB AB, was supposed to match. But the last one was not supposed to, and it did. For example, AAAABBB might appear to match rule 0 above, but has an extra unmatched B on the end. I see. So I suspect that we are indeed like using a function from Parsec which somehow allows you to have trailing junk on it, right? We could run parser trace, but I don't think we need to. I just want to know like contents, text, Parsec, and I have parse somewhere. It's a little hard to search for, huh? Here we go. Well, oh, maybe the empty string. I mean, I guess I could do that, sure. Well, let's examine the parse tree ourselves. We already talked about what this parser does, right? It's an A and a B on the outside, surrounded by two pairs of characters, one of which is the same and the other of which is different. So, as noted, this is two characters that are different. A pair of characters that are the same, followed by a pair of characters that are different. Okay, so like let's here's we can test this a little more directly. Give me back my REPL here. And we'll define our parser again. So it should only match ABA. Okay, first of all, let's do this, right? The first one parses ABA. And if we change it to just parse ABAB, that parses too. So this is clearly the exact problem we have, is that we're allowing trailing characters, trailing junk. Why? Oh, because the parser, I assume, doesn't fail. It succeeds, and yeah, okay, right. The point is you can run, in principle, you can run a parser and ask what was left when you were done parsing. So we could change our parser to require an end of file at the end of input. But I think we should just use a better function from Parsec to say I expect, like I want to know what was left. The most general way to run a parser. Maybe not. Fine, give me EOF. So we will just change compile rules to insert the EOF at the top level only. And if I now let my parser be this and run on ABAB, it says, no, 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 I didn't want this B here. Okay. So if we change this back to input.text, we should be back on the gravy train, right? So to speak. Oh, of course, I didn't change part 1 back to its actual implementation. So we'll comment this out and uncomment these. $195. We had 206 before, I believe, right? Maybe it was 260. It was 200. Oh, all right, I'm not gonna. Well, I guess I am gonna scroll through all that. It wasn't as long as I thought. 206, yeah. Okay, so let's try 195. That's the right answer. Okay. Anything I want to remove before I commit it? I don't need parse error. I guess you're right. I am ignoring parse errors. Fair enough. I didn't end up using lambda case. Fair enough also. Okay, I'm happy with this. So, what's part 2? You realize your matching rules aren't quite right. Fix them. Completely replace rules 842 and 114231 with the following. Oh, that's easy. Right? We already have a map of all the rules. We just need to do something before compiling them. Right? Yeah. And they can contain loops, but that's fine. I'm pretty sure Parsec can handle it. So we didn't end up needing the parse tree concept at all. You only need to handle the rules you have. Handle any hypothetical combination of rules would be significantly more difficult, it says. I don't know. I think I can handle any hypothetical combination of rules. Maybe I'm crazy. Ah, no. Because now we have left recursion here. Right, because 42 can match, well, so 8 is like a list of 42s, whatever 42 is. And 11 is a 42, and then is this like balanced parentheses or something? It's like A, B. All right, let's look at my actual rules. My input here. Right. What are 42 and 31? Who knows? Some junk. So the question is, can I just left factor out the 42s in each of 8 and 11? Like, special case a couple rules for them. Rather than using my existing parsing mechanic. Well, here's the thing. There's no good way to insert something that is not created from a rule into my compilation, right? Because we're compiling from rules to parsers. There's no room for like an int that gives you back a parser. Not easily, anyway. I think we could do it with tying the knot, though, if we made the map a map of ints to parsers instead of ints to rules. We could just compile them all like at the same time. And insert 8 and 11 in there as special. Before we build the rest. And the fact that there are loops should be okay. I mean, 8 is just many one of 42, basically. It's sum 42, haha. That's a band, right? No, sum 41, drat. And 11 is a balanced pair of 42s and 31s, whatever those are. Which rules always match the same set of values? So I guess their point is like, what do 42 and 31 match, right? Was this link about significantly more difficult, by the way? Yeah, a formal grammar, understood. But like, I kind of was building a formal grammar parser. But sure, it's like, I don't know. I feel like, couldn't we left factor this and just like be fine? Not have to know what 42 and 31 are? As long as we can parse whatever 42 was, which we know we can. I don't see why that wouldn't work. And we can tell 11 and 31 apart, which probably we can? It may involve backtracking, but that's okay. That's why everything is wrapped in try, right? So let's try that like kind of simple fix that doesn't require a deep understanding of the problem first. Not the problem, but the input. And if we end up needing a deeper understanding of the input, I'm probably going to pause the recording and go away and think for a while. Because I don't want to have to like dissect the rules themselves as part of this video. So what we need to do is intercept compile rules, which like, I think we need to change compile to tie the knot, right? It's a little, ugh. Compile, compile is right here and it's like really simple. So we could inline it into prepare. But that's not exactly what I want, I don't think. Is it? So I think I want our input not anymore to be a parser, but to be a list of rule, basically. Like so. And then part one can compile it in the totally normal way we saw with compile rules. Part one input rules where p equals what? I lost track of what was there before. It was compiled. Okay. So p is just this. Yeah. And m can just be like that. Right, I didn't finish fixing this. So let's just check that stacked run still works. $195. I believe that was correct, yes? Yes, 195. Okay. So now part two just needs a more exciting compilation process that injects two foreign rules. And more importantly, it kind of ties the knot manually rather than using the map to, well, actually, wait a minute. Right, I was traversing compile. Yes, this is actually somewhat wasteful, in fact. Not that it super matters, but when I parsed, say, rule, I don't know, 10, and it depends on rule 5, I compiled another copy of rule 5. And then when I parsed 5, I said, oh, I need better parse 5, compile 5, right? And then I parsed like rule 11 that depends on 10, and I compiled 10 again, and that made me compile 5 again, right? So this is somewhat wasteful. It would be better to tie the knot anyway. And we don't care about numbers, right? Not for the two special parsers we're inserting don't really need numbers. Okay, so let's write part 2 is an input to int, and it's like gonna be complicated, but the idea is we write input rules s's equals something. Actually, we're gonna implement this whole thing again, huh? Like this should be pulled out, right? Num successes. I don't know. I'll just repeat it. It's like kind of annoying, but whatever. Length. Where? Now the parser is more exciting, right? We need parser to be the entry in a map at index 0. And that map will be m is a map int map to parser parse tree, and it's m dot from list of a slight change. We're going to inline most of compile here, but some of it we're going to do something different. From list of rules prime? Is that a good idea? Should I do that? Is that necessary? I don't see what the point is. I would just be like defining a list here. So it's basically hang on, at index, at index 8 we have sum of m at 42 and at 30 something, 31, 11 we have a more exciting rule, which is do, I guess. Sure. Actually, let's just let it be 11. We're gonna make a special variable for holding the rule 11. Filter. Yeah, filter. Not lm 811 first of we don't have a list though. Okay, fine. I won't use a filter. I'll use a list comprehension, just like I was in part 1. Num production, where rule num production comes from rules, but num does not elem exist? Haskell not elem? Not in like the normal prelude, I don't think. Oh, it does. Not elem. Okay. Num not elem of 811. Okay, everything is busted here for whatever reason. Why? 11's not in scope. I'm okay with that. Num is not in scope, but it's right here. Oh, I didn't write my little arrow. There you go. And now it's just mad at 11. So let's like... I don't know, put some new lines in here so it's a little bit more... like that. And we have to just define 11 now. 11 equals 2. We need to parse a 42. Let before equal M42 after equal 31, I believe. Yeah. Middle we could make this prettier, but whatever. Now we want to parse a 42. So let's say open before. And then it's either after oh, hang on. Why am I looking at middle? Middle is just 11. I don't need that. So it's basically a 42, and then optionally, which I think is called option in option. Optional parse P or nothing. So I think I want optional here. I'm just trying to figure out if I need try. I probably should, right? So we're definitely parsing a single before, and then we parse try optional 11. No, I don't even need this, do I? Before try optional 11 after. And we need optional. And we need to return the right thing somehow. Couldn't match unit with list of parse tree? That's exciting. Am I supposed to say like pure unit here? I don't think I should have to. After should already have the right type, yeah? Yeah. Okay, let's figure out which part of this has the wrong type. It's probably 11. 11 is supposed to have been a parser for parse tree. Okay, 11 is successful, in fact. And this is wrong. What? Oh! No. I thought we had somehow made a mix-up between rules and tuples because we were doing the conversion in the wrong place, but that's not the case. Both of these are tuples now. 11 what? M, I said, is an int map for parser to parse tree. Oh, I didn't compile it. That's the problem. Yeah, I tied together the knot, but none of it is actually compiled. We just have a bunch of rules pointing at each other, and they don't know what to do. Sure. So 8 and 11 are sort of like pre-compiled and inserted ahead of time. So really what I need is to say compile num production here. And then, what are you mad about? Well, but I won't, we'll call it fix because we're like, we'll call it not compile. I don't know. Why? I don't understand why you're mad about production. Oh, yeah, because I removed the tuple thing on one end. And now we say not compile. What exactly is the type of that? It is a function from int and production to parser of parse tree. And if I say not compile is undefined, does everything else now type check? No, it's wrong in exactly the same way. I hate it. Expected, a parser for string that returns a list of parse tree. I don't know why it expects a list. And then here, oh, not compile is actually going to be returning a list of int to parser parse tree because we need to still put it into the map. Still just as broken, huh? Oh, I guess it should be, we should say num not compile production, and that would be okay. And we don't need the int anymore. Parse error. Yes, correct. Ah! What is the problem here? The type errors that I'm getting don't make sense. Oh my god. This plus plus is in the wrong place. It needs parentheses around it. Nope, still just as wrong. But it definitely was wrong a minute ago. I've made the program less wrong, even though there are now more errors. Couldn't match. Okay, so it expected an int map for parser of parse tree, and it got an int map to parser of list of parse tree for some reason. How did it arrive at such a thing? And why did it think 11? Yeah, so it's basically saying, well, this 11... Okay. I think the problem must be that I'm looking up in M incorrectly here somehow. Of course I am. Okay. The problem is that I looked up in M a parser, the one numbered 42. And it gave me back a parser for parse tree, because of course that's what it does. But then I said sum of that, which gives me back a parser for list of parse tree, because you are parsing several of them. And that's fine. If I wanted that value, that would be useful, but I don't. So what I should have said is just take that and throw it away and just give me back a unit, please. Now it all compiles. And by the way, if I remove these parentheses, it will no longer compile. It was definitely wrong. Just wrong in a different way. So now we need not compile, which should be simple. Lit. We can just copy the lit from here, right? Okay, and it's incomplete because we didn't handle the other thing. Not compile of alt options equals. And this time, instead of traversing compile, we can just look up the result in M directly, and there will be a parser there already for us. Where cat is cat of x's. I'm not smart enough to do this point for you right now. Is map. Oh. Is that right? Not even close. Oh, whoops. Parentheses are wrong. And cat. Cat is returning a list of parsers. Yes. And I guess I need to sequence this. To turn my list of parsers into a parser for lists. And now it type checks. I'm just like thinking about it for a minute here. I mean, it seems reasonable. And we're like mapping emptiness over whatever the result is, because we don't care. So what would happen if I said stack run? Zero. It's probably not the right answer, to put it mildly. So they have an example input here. So let's make this my new test input and see like what happens. I assume I'll still get 0, but then I can start diagnosing things, right? What? Oh, I didn't change it. I didn't change what input we read from either. 3. Yes, that was correct, but it should then be 12 afterwards. Oh, geez. How do you diagnose this? Why is this highlighted in... Is that green? It is. Oh, I see. It's just a suggestion, not a warning like this. Or is... That's also green. This is a warning? Yeah, that one's yellow. I don't understand the difference. Well... Well, okay, one thing is I forgot the end of file here. That's just going to make the problem worse, not better, of course. Yeah. So one thing we could do is change is part 2 of input rules s's equal map join of this is stupid map lambda s to parse PSS over s's. I'm missing an equals here. So this will actually print the result, including the error message for each. And we can search for the string that was supposed to have matched but didn't and see if there's anything interesting there. There probably won't be. Now, this is actually kind of interesting. Are these exactly like... I'll be right with you in a minute. I just want to copy that string and this one. And observe, yes, they are the same. So those two strings are supposed to match after updating rules 8 and 11 and before updating them. Let me make sure I understand what we're supposed to do. We're supposed to replace the rule that said 8 must be 42 to be, it's a 42 followed by, it's either a single 42 or it's a 42 followed by one or more 42s, right? So I believe 8 means one or more 42s, and this, in that case that's true. In this case it's also true. So 11 is a 42 and then try an 11. And if it succeeds, then whether it succeeds or not, parse a 31. So what I would like to do then is search in my results. You know what? We can just parse only one thing. Parse p s s s equals this. There you go. That's the input. We're ignoring s's on purpose. So stack run me this bad boy and see if I can have any idea what happened here. I mean, not really, right? Column 15, it found an A where it thought there should have been a B. Great. Did I handle some? Like, should I maybe have a try in here? Maybe. Probably not, but couldn't hurt, right? Yeah, same problem. Let me actually look up how. I don't actually know how sum works in Parsec exactly. If I looked instead at many1, the list of return values. So like, what if the parser reads part of the input and then fails? Isn't that going to be an issue? What's this? I mean, I'm sure looking at the source will be way more difficult to understand than I expect. It's many of p, and many is many accum, which is like a complete mystery, right? Doing this continuation passing style stuff. Let's find a function named walk. Parses. Is seek actually the one from, like, I guess it is. I don't know why they need seek, but okay, you're forcing x's. Then you walk ac x x's. What is ac? It's the accumulator. You just parse p. I don't know, guys. That's like, who knows how this stuff works. So maybe what I could do, I guess, would be to try this myself on a much smaller input, right? Where I define like 8 to be A, let's say, and 42 to be AA, and 31 to be BB. or maybe the other way around. I don't know. We'll say 42 is. Oh, all right. I'll form 42 to be A and 31 to be B, and like that'll be it. And then we'll see. That's a grammar simple enough to understand, and we'll see if it works, and if not, why not. So let's write a new file, test.txt. And by the way, we want to revert this change to part 2, since actually hard coding it did not help at all. And test.txt is going to be 42 is just A, and 31 is just B, and that's it. We don't have to define dummy 8 and 11 rules because they're going to get replaced, right? So, oh, we now need an input string. So let's, oh, we need a 0. 0 is 42 and then 31. 31, right? No, it's 8 and then 11. And then we say, here's one input. So what is it that we should be matching? 8 means many A's. So let's put in like a bunch of A's, and 11 is, I think I already see some of the problem. The problem is we're not backtracking. Because suppose we wrote an 8 followed by an 11, and 8 is like consume any number of A's, and then like, let's say we wrote something much simpler, just A, B. A, B. This should parse, but I bet it won't. Because we've said many A's, and okay, yeah, great. Well, we'll put 8 and 11 in here for reference, actually, since we know, I believe anyway, our job of replacing them is fine. What we put in here doesn't matter, so they're really just for reference. So 8 says match 42, which is A, as many times as you can. And then so it will consume both A's greedily, and it will never give them back because it's parsed successfully. So then when we get to B, or 11, we'll say I need to parse at least one A followed by a B, right? And that'll fail because we consumed the A's that were in front. Even though we could go back and release one of them. Man, this is rough. I don't know how to convince Parsec to give tokens back. Okay, anyway, let's just confirm that this, oh, hang on, I need to change it to run test.txt. I assume this will fail, even though it should succeed. Yeah. Wait a minute. Wait just a gosh darn minute. Part 1 succeeded? Did I make a mistake in my tying the knot here? Because if part 1, I actually put in the real rules that part 2 is supposed to have and gave those to part 1. 8 and 11 are the difficult ones, and it succeeded, but part 2 failed. So I guess I should just use... Man, I feel dumb. So instead of doing all this tying the knot crap, I can just use the original compile method that part 1 is using. How the fuck is part 1 working? Because it parses a 42, which is an A. Oh, it's only working by luck, I think. If I were to change it to like AB, it would break again, right? Yeah. And it should still work. The problem is that my part 1 implementation is timid. It consumes as little as possible, just like by the way I wrote this rule. If I wrote the rule the other way, like so, even though this should be equivalent, part 1 will suddenly... No? Oh, now part 1 consumes all 3 A's. Got it. But anyway, the point is that if I change the rule here, part 1 will still be broken. Yeah. Even though this is equivalent. So the problem is that part 1 consumes a 42 and says, oh, I did it. I'm done. And my part 2, because I used the sum combinator, consumes as many as it can. And neither of those is correct. We need a way to give back input if it turns out to be incorrect to have parsed it, to have consumed it. Now, not exactly the academic literature, but early academic literature on parsers was less performance oriented, and instead of returning either an error or a success, it returned a list of successes, a list of all the ways you could make choices in the input to lead you to a valid conclusion. And it's very expensive because it has to keep track of lots of possible options. But it does yield the fact that you get backtracking kind of for free. If you try the first remainder and it didn't work, you just like throw that result away and you try the second remainder, and like... So I guess my first question is there any way to convince Parsec to behave in this very inefficient way? I don't think so. Yeah, who knows what all this junk is. So... Like, one thing we could do is we could implement like the very basic primitive parser by hand instead of using Parsec. Let's just like ask, how much of Parsec are we using? Digit, character, string, any. Sep end by is kind of nice to have. Choice is not that hard. Optional is not that hard. End of file, not that hard. This would be definitely like a slog, but it's not impossible. I guess the problem is we're also using applicative and alternative stuff. But like we can implement that for our parser too. It's not the end of the world. I still remember there's a lovely like what if Dr. Seuss wrote the book on Parsec? He would have said a parser for things is a function from strings to lists of pairs of things and strings, which always makes me smile. And it's just so impossible to forget, right? The kind of core of a parser is type, we'll call it P of A, is a function from string to list a pair of A and string, right? Where it's a list of ways you could parse an A, and then for each such way, the remainder after you have finished parsing it. And this is how we could get our like backtracking, deep backtracking behavior. But let's first look at Pascal backtracking. Like obviously we can just use try. Oops, I should search for Parsec backtracking, of course. Combinator choice doesn't backtrack. Yes, of course. The rule is that once a branch accepts a token, then alternative branches are pruned. Yes. Like, can I just throw in a million tries and have it work? I don't think so. I guess we could... Maybe we could. Because we have this choice here. That's the only expensive thing, isn't it? Like, I don't think we can say try compose with choice. But I guess, like, what does it hurt to try? Yeah, still 0. Okay. I don't think there actually is a way to get Parsec to be willing to backtrack arbitrarily deep that I can think of. So, like, I don't know. Is there something we can do that, like, understands the problem set up more deeply somehow? Rather than, like, implementing Parsec by hand, which doesn't seem like a great idea. What is the type of sequence, by the way? I always forget, like, if it's which is foldable and what's traversable. No, sequence A, I guess, would be better, but whatever, I'll use sequence. It takes, yeah, something traversable, which in this case is a list, and a list of m's, and gives you an m of lists, yes. I mean, I've never implemented I haven't, well, I've done some really, really basic parser combinator implementations before. And this one doesn't seem that hard. I could just re-implement the tiny pieces of Parsec that I need for this problem, right? I mean, like, why not? Because I'm pretty sure that's the only problem, is like the backtracking, right? So let's a parser for A is a parser where run parser is a function from, oh, curly's not rounds. Okay. And then we can define a couple of primitive parsers. For example, end of file. This is going to take a while, like buckle up, but I don't have anywhere to be tonight, so that's a good exercise, I think. End of file is a parser of unit, right? And end of file is parser of lambda s case s of, if it's null, if it's empty, then it's just we succeed, right? Well, gosh, let's implement all the let's implement in the instances, right? Instance functor, actually that one at least I can get for free. Language deriving functor, it's derived functor, sorry. Deriving functor. Instance monad parser where return x is parser of const x, no, lambda s xs. And it's a little more exciting when you bind, but that's fine. xf is a parser of lambda s2 now we need to call let map. We're gonna do something with the result of calling f of x, f of, here we go. We need to parser p, there we go. Let p1 results equal p of s. And each of those, so when we bind f, we're getting back another parser, right? So P1 results is a list of pairs of x's and strings. And so for each one of them, I need to call f somehow on the values within these things, getting back a parser, and then run the resulting parser on S. So something's not really right here. I've done this before, but it's been a long time. Certainly years since I implemented parser by hand. So we're going to map a function. I'm going to map cat a function, in fact. So let's say do. This is a good idea, actually. So let's just do to begin with. Do. And this is fine because this is a do in the list monad. So P1 results is P of S. And in fact, let's just not name this. And we will bind X S prime, the remainder, we'll call it R, I don't know, the remainder, from P1 of S. And we will then also call we will call f on x, and this will yield another parser, which we should call on R. So we should really destructure parser P2 from fx. No, because fx just returns a single parser. And then we need to call that thing's results run parser P2R. No, this isn't right. What's wrong? Probable cause P2 is applied to too few arguments. Oh, whoops. No, this is right. What's the type of P2 and what's f of x? We called P1 on S, and it returned us a list of pairs of A's and strings. Oh, I destructured P2 twice, didn't I? Am I supposed to just do this? Yeah. So this type checks. Great. So actually, what I really should have just done is run parser fx over R, right? Yeah. And then I can just call this P. Okay. So applicative is easy then, right? Instance applicative parser where pure is return and app is app, and we're all set for that. So I have to import it from monad? App is a kind of historical thing. It was from before before applicative was invented. It was the same operation for monads, and so it exists specialized to monad, but it actually works for any applicative. So It's often a little bit mentally simpler to implement monad than applicative, and so people often just do this, implement applicative in terms of monad. Okay, and what else did we need here? We don't really need... We kind of need alternative, right? Alternative is easy enough, though. Actually, is it parser A? No, it looks good. All right, what is the deal with alternative? Will it tell me? No. Haskell alternative. Control applicative alternative. Alternative. Yeah, so you need empty. And you need or. How exactly is it f of a for any a? Oh, I see. Empty is, it didn't, okay. So for any a at all, empty should match. Okay. So we can say where empty equals, oops, parser of const empty list. What? Do I have to import it? Oh, I see. Okay. Well, let's say P. Q is parser of, and here's where we're going to do the thing that Parsec won't do. We'll backtrack quite recklessly. Run parser PS, run parser QS. Right? Seems good. So now we can start building up our little library of primitives here. And we only need a few of them because hello? It is under version control. Don't you fucking lie to me. Git diff. Git diff source. We were using some, we were using the alternative stuff. That's fine. So we need like digit, character, string, and any. And then we're going to need to implement sep and by and choice. We won't need try. And parse we can do ourselves. So we only need a very small number of combinators here. So let's just write them. Can I just, like, by the way, Haskell backtracking parser. Like, does that just exist? How do I write a backtracking concatenated parser in Haskell? Someone asks. And someone says just use Parsec. You don't need backtracking for this example, which is great, but okay. There's no obvious. Well, here's a Reddit post. A neat way of doing non-greedy parsing with Parsec. Continuously checking the rest of the input past the don't care point to see if it was valid. Well, that's not very useful. This guy's got a parser that like contains junk in it, so yeah. Someone points to polyparse. This is some Haskell package. want to do that. Yeah, okay, whatever. So we're just like not going to do all that. We're just going to write it by hand because what we need is simple enough. So we'll say pred is a function from char to bool to parser of char? Sure. We could probably parse unit here, but it's fine. We'll just do it this way. Pred of f equals a parser lambda s case s of x r where fx, I guess, in that case, it's is it pure? Or is this low enough level that we can't use pure yet? I don't think we can do this because we're inside a parser, right? So it kind of has to be a single match where we matched x and r is the remainder. And otherwise, it's did not succeed. And then we can implement things like char, which is a char to parser char, and char x equals pred equal x, right? Oh, I shouldn't call this what do they call it in Parsec that that consumes a parser? So if we look, it consumes a character, but lets you choose something about it. Parser char. We'll just use that name. Char parses a single character. Any char, okay. So they just don't have this primitive exposed. Oh, there's like a good name for this. Satisfy. Actually, I bet that's in the index here somewhere under S. Yes. Satisfy succeeds for any character for which the supplied function returns true. Returns the character that was actually parsed. So this is what I'm implementing, yes. Okay. And we can say any char. Like, I don't even need to write types for all these yet. At all, really. Any char is just satisfy const true. Digit is satisfy of is digit. Import data. I'm gonna be so mad if this doesn't work, by the way, if there's like so much ambiguity that, but there can't be, right? Data char is digit. They're pretty small input strings. Okay, so what else did we still need to implement? We don't need choice. We can just use asum. We don't need try. All we really need now is string and sep end by, I believe. String actually is... Really? String sequence map char? Map. Yeah. Okay, cool. Right, we have a list of characters, and we want to turn each of them into a parser for characters and then sequence them all together, and sequence just does that. And the last thing we wanted was sep end by, which is like way higher level than all the stuff we've done so far, but that's okay. We can just like write it by hand. Sep end by. is a function from parser A and parser, I don't need parents, sep to, that's a Q, I wanted a P, parser A. Sep end by. Actually, how does sep end by work exactly? I assume that's the right sep end by. Yeah, there's sep end by and sep end by 1, which I guess sep end by 1 is what I wanted, but it doesn't really matter. So sep end by of P and sep equals. Now it gets like complicated. I think. Oh, we were also using optional. That's right. Is that an alternative, by the way? Let's say I went to Google and I asked that question. I have. No, that doesn't make any sense in alternative, I don't think. Because, well, what is the type of optional again? It actually returns a parser of nothing. It discards the result of P. What? It discards the result of P. I guess that's fine because all of our stuff returns unit anyway. I briefly was like, oh no, by using optional we ruined everything. An option actually tries to get the result out. And if it can't, it returns a default value. Okay. But that doesn't seem very relevant at the moment. It's just like, can we implement this in terms of the combinators we already have? It's like, okay, so I think we can, right? We don't need any new primitives for this. Do. Well, actually, success or pure unit, right? Like, where, because like, clearly it's possible to not parse any instances of P, right? So success is do xp, and then the funny thing is we're actually gonna like parse, I don't know. Do I really, let me look at the sep end by that I already had. I said it, sep end by of space. Yeah, so I need to allow it to be ended by the space as well. So So first, we have to say this could succeed without parsing the remainder. Oh, wait a minute. Here's a funny thought. I can actually use Parsec to parse the input still, right? I only have to use my shitty parser for parsing the actual strings in the text file, not for parsing their production rules. So I don't need step end by, right? I just need part 2, right? Or I just need this compile function to work, which is here. And it's like, there's almost nothing here, right? It's got char and like choice. Like it's got, I don't need anything. Yeah. I don't need try. I traverse comes for free. Yeah. I don't need any of this crap. Get out of here. Just like throw all of this away. Well, wait a minute. I need char. That's it. Thank goodness. I was not looking forward to implementing that. And we just need to like rename our thing to B parser for backtracking parser. I'm doing this by hand because there are many instances of parser later on in the file that I don't want to change because they refer to Parsec's parser, the type. Right, so int is a parser for int, and we want to leave that alone. Leave that as Parsec's parser. All of this stuff stays the same. We just have compile return a B parser, right? No. We still can't use compile as written for part 1. Because we can't use B parser because, well, there's no loops in part 1, so that's like fine, right? It's a parser for rule, which we need back like some of the stuff from don't discard that. Don't discard that either. Actually, I don't even need isDigit. I can throw that away, but whatever. Okay, all I really wanted was to get these imports back. So I guess we'll just do it without get's help. And there's some conflicts here. Char. So we'll call this B EOF, B satisfy, and B char. Put an N there accidentally. We shouldn't need try anymore, though. And we don't need choice. Rather, we need asum from here. It's infoldable? Traversable. I think. Alright, third time's the charm. And now our rule parser is back in shape. And compile also parses, which is great news. We have to use BEOF, and now I think part 1 we're ready to kick the tires on that. So let's just say part 2 is const unit. Like so. What's wrong? Add overloaded strings. Oh, I don't like that at all. It's telling me, it's finally, like, the file finally parses, and now it's like, I don't like what you've done. This should be bchar. I wish it would show me, like, okay, what's the issue here? It's a parser. And well, first of all, I forgot the second half of the function, which is otherwise it fails. Oh, I mixed up. This should be a tuple. What are you mad about, though? Oh, there is a single result. Yeah, there we go. There's a single result, which is you parsed successfully the end of the thing. Okay. And this still doesn't compile, but that's fine. Line 76 fails to compile. Here. Parse is wrong. Run parser now. Okay, sure. So the issue here is we don't want the empty string anymore. And this is still incorrect because it will turn a list of multiple results, and there could be ambiguity, although I don't think there is. So what we really want to say is so we ran the parser. One, let's say, where tree not null tree. So if we got at least one result, we yield a 1. A unit, let's say, for clarity. It actually compiles now. So let's stack run and see what happens. Using our new janky parser. Maybe we should call it jparser, huh? 1 result. Oh, of course, because I'm still running on my test input. But this is great news, because my test input is this. It's the part 1, it's the hard part for part 2, right? And we got 1 result. It found a match. And I believe if we do this, we will still find a match. Actually, let's just like test several of these. They all matched, right? And if we add another B here, this should still match. It consumes 2 A's and then 2 pairs of open close A's. Yeah. So I'm happy with this. And let's just give it input.text here. The real input. 195. It's still correct. Perfecto. Now, we do need to actually use part 2. Like, we still need to do this tying the knot because it's the way to avoid an infinite loop of compiling regex or parsers that depend on other parsers. But the good news is we already did that. So we just have to drop this try garbage. And instead of optional, we can just say 11 or 11 or nothing. And instead of choice, we'll say asum, and instead of try, we'll say nothing. Looks good. It compiles. Now this might be slow because we are exploring. Nope, still 0. Fuck. Ah! Why? All right. Let's just double check that if we give this test.text, it fails. So I did something weird here in like replacing stuff, right? So I think my like this thing must be busted somehow, right? Well, can I just feed it like an ordinary rule and have it be compiled along with everything else? I think so, right? We're already doing the tying the knot stuff. Yeah, I don't need fancy settings for 11 anymore. So I think what we can say is not compile of rule production of, oh, it's not a production, right? It's an either a lit or an alt. Well, okay, let's give them special names just because it's convenient. But we'll implement them not with parser primitives, but the same way everything else is done. So 11, 8 is a production, and so is 11. And 11 is an alt of lit, no. How do we handle ints? Okay. So it's either a 42, an 11, and a 31. These need commas. Also, 1 is that key. Or it's 42 and 31. And 8 is... Oh, it's a 42 and optionally an 8, basically. So it's an alt of either just a 42 or a 42 and then an 8. Okay, this also compiles. Still says 0. I'm upset about this. Isn't this exactly the same as what I was parsing? Oh, I'm still using a parser instead of a B parser. This type checks again. So maybe my not tying thing was actually right. I bet it was. And I didn't need, but this is actually cleaner, I think, than like having to implement them with parser special sugar. Just say, here they are, these are the new rules. And let the existing parsing stuff handle it. 309. Perfect. We got a larger number. That's what I was hoping for. That's the right answer. Okay, boy, that was a little exhausting. We spent almost an hour like re-implementing the very, very bare bones of Parsec, but it was a good exercise, I think. What have we done so far? Good. Okay. So we don't need to add. Actually, it's fine to add test and example. Let's just make sure there's nothing I want to clean up first. We don't need his digit. We don't need EOF, I guess. We don't need parse. We do need parse because we're using it to handle fully backtracking parser for use in parsing the input strings. Full-featured, non-backtracking parser for use in parsing grammar. Fine. My one thing without a bchar, the function from char to b parser char. You got me. The one thing I had without a type signature, I will give it one. Okay, this file is like, it's a mess. The order everything is in is just bizarre. Really, I should like move all this bparser stuff to another file, but I like don't know how to structure Haskell projects, so I'm not going to. Hope you guys enjoyed this little exercise in like how to implement parsers by hand, which is, I think, a really cool thing to be able to do. And as you can see, like, shockingly easy. It took me a little bit of stuttering, right? Mostly in Monad. But all this other stuff was super easy, and then it was just like I was trying to implement sep end by and then realized I didn't actually need it. And I don't even need like bsatisfy either. I could just use bchar and it would be fine. But bsatisfy is kind of a nicer primitive. I don't know. Like, let me know what you guys think. This was definitely a long one, but I enjoyed it. It was a good chance to get to use, like, I don't know. One of the reasons that Haskell is nice to write parses in is because you have like the applicative syntax and stuff, right? And you might say, well, it's because you have all these great parser libraries. But as you can see, like the core, like really, if you were to implement really bad versions of those libraries, it's really easy because all the the important combinators that you want don't have to be special case to parsers, right? You just make your thing applicative and functor and monad and alternative, and it participates in all these amazing things that are in the standard library for lots of different types. Right? I mean, we didn't use that much, right? You know, really, we just had like, we used asum and sequence, right? We got those for free. We didn't write them. You know, choose from any of a list of things, string together a list of things and choose and take them each in a row. Like, you just kind of get it for free. I think that's really nice. Anyway, I guess I'll just, that's all for today. Thanks for watching, and I'll see you next time.